second part of photosynthesis. It's light independent, meaning it doesn't need sunlight to operate. The Calvin cycle happens in the chloroplast, more specifically the stroma, which is the aqueous environment around the thylakoid. Its goal is to produce G3P, which would then form into glucose. It's composed of 11 enzyme-catalyzed reactions, but for our sake, I'm just going to divide it into 3 phases. Phase 1 is CO2 fixation. Phase 2 is the reduction of 3-phosphoglycerate to glyceraldehyde 3-phosphate. Phase 3 is the regeneration of RUBP. Phase 1. Carbon fixation is converting carbon dioxide, an inorganic compound, to a carbohydrate or a sugar, an organic compound. Basically, you want to incorporate carbon into a carbohydrate. So CO2 reacts with RUBP, which is a 5-carbon sugar. This then makes 2,3-phosphoglycerate, a 3-carbon molecule. This process is also known as C3 metabolism. Phase 2. So, now we have 2,3-phosphoglycerates. We're going to convert them into G3P through reduction. You give 3-phosphoglycerate a phosphate, which you got from the ATP hydrolysis. The NADPH you got from the electron transport is then oxidized to NADP+. The 3-phosphoglycerate then gains those electrons, so it's reduced. Because of that, G3P is now made. Also note that 6 G3P are made from this process. Phase 3. Out of the 6 G3P made, 1 of them leaves to produce glucose. The other 5 gets recycled to remake RUBP. Note that these 5 remakes 3 RUBP. 3 ADP and 3 inorganic phosphates are made from another ATP hydrolysis. Why? To give RUBP energy. Now that RUBP is regenerated, the cycle can start again. So, to make 1 G3P, you need 9 ATP, 6 in phase 2, 3 in phase 3, and also 6 NADPH from phase 2. But to make 1 glucose, you need 18 ATP and 12 NADPH because you need 2 G3P to make 1 glucose. Thus, the cycle must do 2 full turns.